All right, yeah, so let's talk about linear equations in two variables. And so let me just write up here a couple of examples. Y equals 2x plus 3. Y equals minus 3x plus 4. And then 2x minus 3y equals 6. Yeah, so we've been talking mainly, I mean, some of the models we've done have had two variables, but we are going to be a lot of times talking about equations in two variables. And this is our next venture into that. It's linear equations in two variables. I've written three of them up here, and the reason those are linear equations in two variables, linear because they're to the first power. The y and the x are both to the first power. We'll look at, you know, other equations in two variables that is not the case, where you have different powers for at least the x. But for linear equations in two variables, it's y to the first and x to the first. All right, now, of course, what we're going to be doing with these is graphing, and you may know some about this, but let me just sketch these up here. Yeah, if I did a table or various ways to do these, here's what I'd get. Something like, I mean, it doesn't have to be exact here. I'm just kind of sketching these in. That'd be the graph of that one. Table on this one. Be probably more like that. And then this one. This. He said, if you know how I did that, but that's fine if you don't. We're going to talk about it. All right. Yeah, so if I sketch the graph of linear equations in two variables, of course, what we see on all of those is what? What shape graph? They are lines. And, you know, that, not necessarily the only reason for it, but why it's called a linear equation. Because the graph of such things, x to the first, y to the first graphs, those are lines. And we'll talk about graphing those. It's not that difficult, really. But one thing about linear equations in two variables that we really want to explore or know about is that the slope of those lines. Now, multiple things to know about slope. First of all, one way that the way we designate slope is with the letter M, right? M is the slope. And then there's several ways that we talk about slope or designate slope. Can you give me one of them? How do we designate slope? Rise over run? Okay. Yeah, slope is defined to be the rise to the run, the ratio of the rise to the run. All right, so and it depends on how you want to do it, but just to look at it, what that means is how much you rise from one point to the next, so I'll rise this much and run that much, right? That's what we mean by rise to run. How much it rises to how much it runs. It's vertical change, horizontal change, which I guess is another way to designate it. It's vertical change ratio to horizontal change. What else do you know about slope?
y2 minus y1 over
Okay.
x2 minus x1.
There's a slope formula, isn't there? Difference of the y's over difference of the x's. y2 minus y1 over x2 minus x1 is usually the way that we designate that. But that's just between 2 points, the slope between 2 points on the line. Yeah, as you take the difference of your y's over your difference of the x's. x2 and y2 is 1 point, x1, y1 is the other point. So yeah, it's so use these again. The first point's x1, y1, the second point's x2, y2. So yeah, you do the difference of the y's over difference of the x's, and that's another way to remember it, difference of the y's over difference of the x's. So the y's are on top, right? X is on the bottom. Okay. All right. Now, let's go ahead and talk about positive and negative slopes here a little bit. Yeah, we can see here, maybe I didn't do such a great job of graphing my line here, but turns out this one, the rise would be 2 and then the run would be 1. We'll talk about that more in just a second, but the rise to run ratio here is 2/1, which means our slope, M, is 2/1, which means the slope is positive 2. Whereas over here, if I run from this point down to this point, the rise, we go down 3, and then we run 1. Like I said, we'll talk about that if you don't know where I'm getting that. But the slope here, the rise over the run is -3 to 1, so that's a -3. So this has a positive slope, and this has a negative slope, and that's sometimes helpful to know what you're dealing with, whether you have positive or negative slope, and you notice the difference between the two is what?
Where the lines go.
This one is from left to right going uphill, sometimes we call it, and then negative slope here is running downhill, right? So positive slopes are uphill from left to right, going left to right, and then negative slopes are downhill. So what do we have on this one? Positive or negative?
Positive.
That one's going uphill, isn't it? So this would also have a positive slope here. Now, just for so these are uphill, left to right, and these are downhill, left to right. And it's, like I said, that's helpful sometimes to know what kind of slope you got. All right, easy tell. Okay. Now there are two other possibilities that could happen as far as positive and negative. Sometimes you don't have positive, nor do you have negative. For example, if you have a horizontal line, well, it's not going uphill, it's not going downhill either. Zero slope. Yeah, it has a zero slope. So horizontal lines are zero slope, and then the other alternative, I guess you might say, is a vertical line, straight up and down. And on a vertical line, the deal is on it has, we call it undefined slope. So a vertical line has undefined slope. Different reasons for that. Go into that later on, but just be aware of that. Okay. Any other thoughts or concerns on that? All right, so yeah, it is important here that we will use this slope formula, let's call it. Be sure you can work with that. And usually we just remember that m equals y2 minus y1 over x2 minus x1, but yeah, we'll officially call that the slope formula. So if I refer to the slope formula, that is what I'm meaning. Okay, so what is the slope of the line between, with points number 1, 4, 7, and 9, 11. What is the slope of the line? What is the slope of the line with points 4, 7, and 9, 11? So it's just plugging in some numbers, right? Like I said, it's just designate the y's and the x's. It's the second y, so it's 11 minus first y, which is 7, over second x, which is 9, minus the first x, which is 7. So you got 4 over 2, which does simplify to 4, but 2. So this line would have a slope of 2. And it doesn't matter which 2 points, right? Which, did I do something wrong?
Yeah, the bottom.
Just checking. All right, let's see. 11 minus 7, 9 minus, not 7.
4.
Ah, okay. Thank you. 9 minus 4, so you got 4 over 5. 4/5. Thank you. Just checking. All right, now, so what I was saying though is that it doesn't matter which 2 points, so we could have had 2 other points on this line, it would have the same slope, wouldn't it? So the slope is consistent throughout the whole thing, the whole line. You know, it can get, the trickiest it can get, I guess, is throw in some negative signs. So let's say we got the line with -4, 2, and 6, -3. And so I want the slope of that. So what we got there? So we got second y, -3, minus first y, 2, over the second x, 6, minus the first x, -4. So yeah, like I said, that's about as tricky as you can get on these, because you got to watch your signs. First on top, you got -3 minus 2, that's -5. And then on the bottom, what you got?
10, negative 10. Or
Negative
positive 10.
Positive 10, all right. Yeah, because you've got 2 negatives, so that's actually going to be a positive. So you got 6 plus 4. And yeah, it's just like any other fraction you would reduce. -1/2. So in that case, our slope of our line would be negative. So that one, we plotted them out, be downhill, goes uphill on the other. Okay, well, yeah, and the reason, let me go ahead and mention real quick, the reason that vertical line turns into undefined slope, and this, you know, this does come up, this same thing does come up other times, so let's go ahead and talk about it, it wouldn't hurt. All right, so let's say we got, here's a vertical line, wouldn't it be 4, 3, and this is number 3. 4, 3, and 4, 5. If you plot those 2 points out, don't we have a vertical line? 4, 3, and 4, 5. Vertical line. Well, we don't have to know that, just other than the fact that I'm showing you why a vertical line slope is undefined, because, yeah, so if I compute the slope here, what happens? 5 minus 3, second y minus first y, over second x minus first x. You get 2 over 0. And what's wrong about that? Yeah, the 0 denominator. That's why a vertical line has undefined slope, because you have 0 in the denominator. And 0 in the denominator is undefined. You can't define that expression. 0 on the top is okay, but 0 in the denominator, that's an undefined. Okay? So that's why when you have a vertical line, you get this undefined slope. Okay? All right. Well,
I do have a question.
yes.
If that was on a homework or a test or something, would you accept the 2 over 0, or would you want the undefined slope as the answer?
For full credit, you need to say it's undefined.
Undefined.
Yes. Because, you know, that's, you know, if you have 0 over 2, 2 over 0, this is 0, and that's undefined. So, you know, what I'm saying is to be sure, I know that you know that that's undefined. Yeah. Be sure to put it as undefined. All right. And this, now with 0 over 2, that's just 0 slope, which, what we say, which kind of lines have 0 slope? Horizontal line. So that'd be a horizontal line if that came up, but yeah. All right. Well, let's see. Moving here along. Okay, so let's talk about the equations of lines. We looked at the three examples of linear equations. Well, turns out equations of lines, there's many forms of them. I like to focus on one form of them, and that is the slope-intercept form. Usually when we're trying to find the equation of a line, slope-intercept form is precisely what we're looking for. And slope-intercept form is y equals mx plus b. That's the slope-intercept form of the equation of a line. Because what information is given when you have y equals mx plus b? M is the slope, and b is the y-intercept. So that's why we call it slope-intercept form of a line, because that information is just, you can read that right off the equation, right? Y equals mx plus b. All right. So yeah, that's, like I said, that's my preferred form, or usually the preferred form. That's the form we want. So what that means is that gives us a way of graphing fairly easily graphs of lines. If I've got y equals mx plus b, the graph of that line is not terribly difficult to do. So let's say I've got a graph y equals 3x plus 5. So that's not hard, but I mean, you have to recognize it's a line, right? Why is it a line? It's in y equals mx plus b form. So this is a line in y equals mx plus b form. And what is my slope?
3.
M is 3, and b? 5. Okay? And more specifically then, yeah, m is 3, b is 5. Well, since I'm graphing a line, all you need is 2 points, isn't it? 2 points to determine a line. So with those information, those aren't my 2 points, but with that information, that's going to give me 2 points. 1 point, and then I can go to another point. So since I know it's a line, 2 points to determine a line. All right, so B is specifically the y-intercept, isn't it? And so that's our first point. Go to the y-axis and go to 5. Now the other point is not 3, but we know that the slope is 3 here, and we know that the slope is 3, and it's rise over run, isn't it? Move down here. So my slope is 3, and I know slope is rise over run. So I know, that's what I know. I know slope is rise over run, and I know the slope is 3. Well, how does that help me? Well, if I think of 3, not as 3, but as, how could I write that as a fraction? 3 over 1, yeah. If I write that as a fraction, 3 over 1, ratio, however you want to think of it, what that's telling me is, right, rise 3 and then run 1. If I rise 3 and run 1, that gets me to another point. So from one point to another, if I rise 3 and run 1, that gets another point. So let's do that. So I'm going to rise 3 and then run 1. And that puts me at another point. 2 points to determine a line, so I know the line. Yes? Okay. So that's, I mean, it took me a while to go through that because I was talking about it, but that's a pretty quick way to graph lines. You know, you can still use table. Table would be fine, but you know, this will work. All right. So, any questions on that one? Let's try another one. All right. So let's graph. y equals negative 2x minus 4. All right, so this one we've got the m is negative 2 and the b is negative 4. And so my graph, and I know it's a line, so we go down 4. That's going to be the y-intercept, negative 4. And then my slope's negative 2, or negative 2 over 1. What does that mean?
Down 2 over 1.
Rise is negative 2, run is 1, so it'd be down 2 and over 1. Yep.
No,
So
which way over?
Down 2,
To the right, wouldn't it?
down 2, over 1. Yep. Yeah, the top is the negative. I took the top as negative and the bottom is positive. Why wouldn't it be both positive? I mean, both negative, sorry.
Because I'm negative positive.
Yeah, if I did a negative 2 to a negative 1, down 2, back 1, that's not a slope of negative 2, is it? That's positive 2. And so, yeah.
That'd
So
be
one of them
going up to
positive, one
the
of them
right.
negative. Do what?
That'd be driving up to the right in the graph.
Yes, that would not be a negative slope, exactly. All right. Okay, any other questions, thoughts? All right. Let's talk about this one. Three x minus 2y equals negative 8. The goal is this graph, and unless it specifies here, we have our option. I don't care which way you do it. But let me talk about 3 ways here. The first way I would do it, okay, so first of all, we notice here that this one is not like the other two, other than it's x to the first and y to the first, because why?
Y is on the same side as x.
Yeah, we don't have it in y equals mx plus b form. So I can't read the y-intercept and the slope right off of that graph, or right off that equation at the moment, right?
We could put it there.
So that would be one way would be to put it in y equals mx plus b form. But that's not the way I'm going to do this one. But that is one possibility. You could do that. Put it into y equals mx plus b form. The way I like to do these is I call it the intercepts method. Get the intercepts. Because we talked about y-intercept and x-intercept. If I've got the y-intercept, or want to find the y-intercept, how do I do that? The y-intercept, how do you find the y-intercept?
Set x to 0.
Set x to 0. And so that's, like I said, that's a pretty quick way of getting that point. It's going to be negative 2y equals negative 8 divided by negative 2 is 4. So the y-intercept on this thing is going to be 4, or 0, 4. So it's going to cross the y-axis at 4. Then the x-intercept, similarly, is easy, pretty quick to find. You set y equal to 0 to get the x-intercept. And of course that makes that term 0. Then divide by 3, you got negative 8/3 is my x-intercept, which is about, well, it's negative 2.6 repeating, 2 2/3. So across the x-axis at negative 2 2/3. Negative 8/3, negative 2.6 repeating. Yeah, so that gets you to 2 points. Fairly quickly. So I wanted to mention that. Now, other ways, like we already said, what are some other ways we could do it?
You could
Put it into y equals mx plus b form. How would we do that? And we'll talk about that more later on, but well, the way you do that is you just solve it for y, right? Solve the equation for y. Get y on the side by itself, subtract the 3x and divide by negative 2, and that gets you your y equals mx plus b form. We'll do that in another problem along the way, but and you're perfectly welcome to do that. And then also, what other way? There's always, use a table, right? X and Y values. Choose some X values, plug in some Y, and find the Y values. All right, so, that, many options there. Any other questions or concerns on that? Okay? All right. Well, our other, we talked about graphing the lines, all right? So what if we go the other way? What if I have some information about the line and I want to find the equation of the line? So let's talk about finding equations of lines.